First, so this is like the Obsidian or web graph kind of view, showing the relational nodes of network device assets with all the way down to like the customer endpoint, like OLTs, ONTs, and then continuing up the how do you explain it, the teams, and showing like the critical outages and how like we tie in each AI model or each kind of predictive model to help assess whether issues occur within tickets, and how different systems communicate with each other, based off of the many teams we already have, right? So I'll kind of go through a little bit of this, and then I have a diagram or a more technical diagram kind of breaking down a little bit of what I have going on, and even like what it would look like for production. Um,
Cool.
but okay, so where you enter the graph. If you guys have already seen it, you kind of access the portal. It would usually be used by like say duo multi-factor authenticator or another MFA source that we choose. I know Verizon might be coming in soon, so they might have other ideas as well. But right here you have like Circuit Charlie, a diagnosis infrastructure analysis agent who basically triages like the tickets and gives a diagnosis of like what are these outages are stemming from. So like the 89% confidence is a fiber trunk severed by construction equipment at SP whatever California. These are like specific trunks or locations within our network that are possibly severed by a construction crew or so on and so forth. And then obviously we have the continuing down, we have the other agents right here. So if we can kind of see how the ticket is, we see that the diagnosis analysis has been complete. And then this is where the human loop kind of feeds in, and we can kind of choose, like as a knock specialist, we can kind of choose, hey, do we want to send out a field repair required, or like this is the percentage of how like the field repair, or do we want to hand off to like priority Parker for escalation, or do we want to dispatch the crew immediately? So based on our knowledge and intelligence as a knock team, we can understand whether we want to escalate or dispatch. So in this case scenario, we're hand off to priority Parker for escalation. So priority Parker is our alert triage and ticket consolidation, basically compiling all those many tickets that we see, and then basically give us a report back saying receive diagnosis analysis from Charlie, prioritizing based on customer impact and SLA requirements. Do we want to continue to dispatch Diana or escalate the priority level? So we're going to continue to dispatch Diana. So dispatch Diana is going to like relay the team or find the crew members that are on site near the location where the fiber trunk has been severed, and then dispatch equipment delivery and like find the equipment that we need to go fix that issue. And then we can continue to Sentiment Sophie, which Sentiment Sophie is our more customer facing AI agent, where they will automatically recognize the people that have been affected by this. Say, for example, like Thomas Anderson, or here if we continue out, yeah, like Thomas Anderson, or the people that are affected by this severed link, right? And then we can, after all this communication has been happened, we can continue to deepend Louis, right? So within deepend Louis, we have like the customer communication active. Deepend Louis is basically the all in all like boss of the AI agents, making sure everybody's in check, and teaching us or the newer like network engineers and architects and whoever is really the stakeholders within this, on the I guess like the historical knowledge about what happened and how to further prevent this from happening. So then we can like basically complete the workflow or start training sessions to train our team members and so on and so forth. And then if we go to alerts, you can see the alerts based on like the criticals, the P2s, like as warnings, and P3s based on who's like the most important value faced customer that we have, say like businesses or our end customers like at home, our residential customers. And then you can see like the metrics right here. These are more metrics for like executives or directors or managers to kind of see what the heck is going on. Um, So you can see right here is like, for example, for like 4,991 affected, and then you have the SMS deflection rate, and other key metrics that are installed, which obviously we can expand on to what metrics we really, really want. You can obviously see them here also in the analytics dashboard, basically stating like how many outage durations we have, like 4.2 hours. What does that reflect into NPS impact? What does that reflect to churn risk? And then how much money are we losing per outage duration? You know, going really, really deep into this. So if we click off that, and then click on agents, I guess, do we have any questions on this real quick before I go into anything else?
Let me just touch on the analytics real quick. Just like that's more of a pulse of the outages and how like Circuit Charlie can prioritize the task. That our priority Parker can prioritize the tickets and the outages and which one gets taken care of first, essentially. And that's more of a visualization of that. Sorry, go on, Jonathan.
I was just gonna say I have a ton of questions, but I'm gonna wait until the end because I could probably spend like an hour asking questions. So I'm just like,
Yeah.
So I don't have any questions right now. If anybody else does, go ahead. But just letting you know, I'm gonna have a ton of questions at the end.
Just keep in mind it's a prototype. That's
oh
really
yeah.
What
no, I mean in a good way
of
of questions.
So.
Yeah, no, that's fantastic.
Yeah. Okay. Anyone else have any questions? No, I can't. Okay.
No, yeah, I'm just keep going.
Oh, okay, you're good. Okay, cool. So we're gonna take a step away from this graph real quick. Again, this is just the prototype, but where the idea came from is where I really want to highlight and kind of what it would look like in terms of systems and what would it look like, possibilities in terms of production. Okay, so real quick, do you guys see my screen at all?
I can see it.
Yeah.
Okay, yes. Cool. So I'm going to walk through a little bit of this, and then we're going to go straight to the diagram. Okay. So hi, everyone. My name is Shazi Musa. And before we jump into the architecture, I want to share how this whole idea came to life. My journey in tech goes way back, like 7 years old, cracking open our first family computer just to figure out what this strange alien machine was and why it made so much noise. I've always been obsessed with understanding how things connected under the hood. Fast forward to my teens and early adulthood, that curiosity led me into a tool that completely changed how I think. Obsidian, specifically the graph view. For the first time, I've actually seen how ideas, systems, notes, and concepts were connected. It wasn't just a note-taking app, it was a map of relationships, of a living network where everything had a link, a direction, a reason. That visual way of thinking stuck with me long before I stepped into corporate IT. Then at 18, I started my first tech job selling Intel laptops at Best Buy. I wasn't thinking about KPIs or conversion rates. I thought it was just helping people in need. Next thing I know, my manager tells me I generated $120,000 in revenue on my own. Cool number, but it didn't mean anything to me at that time. What excited me was understanding all this all this technology actually worked together behind the scenes. So I kept going. I landed my first IT internship, and 2 weeks later, I became a database admin, and then a network admin, then a security, then the guy who just gets tagged for everything. Ask Shaw's, he'll know. But the deeper I went, the more I realized the real issue, it wasn't complexity, it was the lack of visibility. Everything was siloed. Logs here, alerts there, tickets somewhere else, and customers mad that the app portal was down, configuration buried in an email from 2021. There was no graph, no way to see the system the way Obsidian Graph let my own mind as an interconnected network of my experience and knowledge from my learning. And that's where the pain hit. I couldn't keep up. I couldn't remember old redundant processes. I couldn't be everywhere at once. I definitely didn't have time to rebuild Lucy's report while production was crashing. My family wasn't taken care of for the amount of responsibility that I had. Then the next alien arrived, AI. LLMs love structure. They love pattern. They never forget relationships. They think just like an Obsidian graph, everything is a node, everything is connected. And right there it clicked. Let's focus on automating data flows and let's let LLMs do the work while we act as their managers. I soon left that position and joined Frontier. I decided to start from the bottom to understand what's under the hood of Frontier, which led me to where we are today, GigaPulse. So, diving down, let's walk you through the GigaPulse architecture. Think of this diagram as an anatomy of the entire system, from raw logs all the way to AI-driven decisions. We'll trace data through each stage, and I'll show you both what we're demonstrating today and what it takes us into production. So we'll first dig down into layer 1 to layer 3, and then we'll go into layer 4, and then continuing off with layer 5. We'll start at layer 1. At the top of the layer 1, the source systems. This is where all our data originates. In this demo, this is where our raw CSVs lives. We pull in 3 categories of CSV data, totaling 14 distinct files to represent our operational reality. Events, which are logs of when and where problems occur. Customers, who's subscribed and who's affected. Infrastructure, our fiber optic cables, equipment locations, and how everything really connects. The enterprise production visibility of this right here is crucially, this architecture is designed to scale. It's a live environment. We replace these CSVs with real-time connectors. Customer and ticket data will stream directly from Salesforce Service Cloud via REST APIs, giving us a live billing and support ticket updates every few seconds. Infrastructure telemetry will be ingested via Kafka streams into Databricks, our data modeling platform, handling millions of signal events per second from our optical line terminals or OLTs. Basically, the white little boxes that are if you guys are Frontier customers, the ones that are connected to your guys' houses. Okay, these are basically what we call the equipment that powers fiber internet. So if we go down to layer 2, data flows through layer 2, our ETL factory. ETL stands for extract, transform, and load. Pulling in the data, cleaning it up, and organizing it properly. We made a Python script that acts as a lightweight ETL engine. It reads files, cleans schema violations like missing dates or mismatch IDs, and instantaneous strict SQL alchemy objects to ensure quality. What would this look like in production? To handle petabyte scale data, we transition this layer to Databricks Delta Live Tables, DTL or DLT, an industrial strength assembly line for data. Instead of a Python script, we use DLT pipelines to define quality expectations. Bad data isn't just rejected, it's quarantined into a separate area for analysis, ensuring our lakehouse remains pristine. Delta Lake, the underlying storage, keeps a full history with ACID guarantees, meaning for every operation either fully completes or fully rolls back, no half finishes change. This gives us the ability to reprocess history instantly if logic changes or something a simple script can't do. At layer 3, this is our data persistence. Layer 3 is the vault, our single source of truth where all clean, organized information lives permanently. Within the demo, we use a GigaPulse relational database that's built on SQLite. It enforces 3NF normalization with strict rules through foreign keys, ensuring that an outage cannot exist without a valid customer. The database won't allow orphan records. For production, we move the SQLite database to Databricks Lakehouse architecture with 3 layers, also known as the Medallion architecture. At the bronze layer, which holds the raw Salesforce and telemetry dumps exactly as they arrive, stored in Parquet format, nothing modified, nothing archived. At the silver layer, this cleans and joins data connecting between related records. For example, matching a Salesforce customer ID to a network ID. We track history using type 2 SCD or basically slow changing dimensions. And then at the gold layer, we use aggregated metrics and pre-calculated summaries ready for instant querying by the AI agents. Think of this as having answers already prepared. This decoupled storage and compute model allows us to scale storage infinitely on S3 or Azure Blob, also known as cheap cloud storage.
Quick thing, are you now in the purple area in the bottom left-hand corner of the screen?
Not yet. So
or are you still in the orange area?
Yeah, so
you're still in orange? Okay,
I've created a production view.
Mm.
This is what we have right now. I'll show you guys the production view right after.
Cool.
Cool.
We are running a little short on time, Shaz, so.
I'm trying already, guys. Okay, so we're just gonna skip to 4. All right. So layer 4, API engine and the API and Graph Engine and AI agents. Layer 4 is the nervous system, where the brains of the operation live. Within this demo state, we expose data via fast API backend that serves data through REST endpoints. Behind it, we use a graph query engine to build the network topology and memory, understanding how every cable, switch, and customer connects to each other. Inside lives our AI agents. I only demonstrate 3 in what I'm saying, but we can scale, or we can create AI agents or models infinitely. So the topology agent uses pathfinding algorithms like GPS directions to suggest, for example, reroute via backup trunk B01 with a fiber cut is cut when a fiber cut is cut. A diagnostic agent analyzing patterns to identify fiber cut root causes, distinguishing between a fiber cut versus a power failure. Our sentiment agent reads customer feedback and detects churn risk from NPS scores to predict who might cancel the service and all the other metrics we track as customer-facing representatives. The enterprise production vision, security and scale are paramount here, and we are enterprise-grade protection and massive scalability. For authentication and security, we implement dual multi-factor authentication. And when an agent suggests a critical action like rerouting a fiber trunk, the engineer receives a dual push to approve it. No autonomous change happens without secure verification from a human. All service communicates using MTLS. Basically, both sides verify each other's identity. We follow zero trust principles all in all. Never assume anyone's trustworthy, always verify. The orchestration at scale. The agents themselves run as containerized microservices on Kubernetes. And then we use Istro as a mesh service, which wraps everything with automatic retry logic, circuit breakers, and a whole bunch of other stuff. Skipping down. Then we go to layer 5. So this is the layer 5, the consumption layer or the presentation layer. Finally, at layer 5, this is where the user interface, what people actually see and interact with. Within the demo state, a web application with a interactive topology graph that visualizes the blast radius of outages in real time, built as a React app with WebSocket connections. It uses force-directed graphs to show how outages spread through the network. The enterprise production vision is, and in production, this becomes a role-based experience where different people have different things that they see based on the role. For the executive view, high-level dashboards showing regional health, mean time of repair, and SLA compliance, etc. Engineering view, detailed node level graphs with write access to close tickets, document repairs, and trigger automated workflows. For the dispatch mobile tech, we have a mobile app that only shows their assigned geographic area. Skipping down. By integrating with Salesforce Identity SSO, we will make sure everything's like protected and safe. And then the whole interface is served through a cloud network or a CDN with load balancing, so it loads fast everywhere worldwide. Putting it all together. So what you see today is fully functional prototype, but the architecture separated into module, source ingestion, storage, and intelligence layers is ready to be lifted and shifted into world-class Databricks plus Salesforce ecosystem tomorrow. Every layer is designed independently using microservice principles, small focused programs that do one thing well. This means that we can upgrade the database later without touching it, the AI agents, or swap the front end without affecting data at all. The architecture follows industry standards for horizontal scalability, adding more machines instead of bigger machines. Fault tolerance, one part failing doesn't crash everything, and even event-driven design. We built something that works today but scales to enterprise tomorrow. Do you feel the pulse? Good. All right. We'll go with that. Do you guys have any questions at all?
I would say that in the case of Darius, Aditya, and Michael, they have a hard stop in 4 minutes for another call they have to do. I can stay longer, so if they have any questions, ask them now. And I was wondering, like, we could go a couple of minutes past 4 so that, maybe James and I could ask some more questions, if that's okay.
Yeah, I do apologize for extending you guys even more, but yeah.
Cool. Darius, Michael, did you have any questions in the remaining couple of minutes?
Nothing looming, but just wanted to ask you, Shaz and Shannon, if I can just reach out to any of you maybe another time just for a follow-up or maybe like another demo. This is definitely really cool, but Definitely would want to get more, deep down at a later time. That was okay with you both.
Of course.
Cool. I'll just maybe ping on Teams or email, but I'll try to find a time. I know we're approaching the holiday season, but I'll try to see if any of you guys are free and we can just jump on another, session. But this is really cool, shots. Thank you for demoing this.
Of course, my pleasure.
Cool. All right. Well, then I think then if you don't mind, I'll ask some follow-up questions. Michael, Darius, Aditya, feel free to whenever to go to your next call. So a couple of random questions. So like high level, Shah's like, so you work in the NOC, so you kind of understand, if I understand correctly, like you kind of understand like where all the skeletons are buried and the tribalistic knowledge of like what all the different events mean, which data tables mean what they say, or what they might not mean what you think they mean. Like
Yes.
you're kind of in that situation, right?
Yeah. You, with experience from the past, dealing with like databases and dealing with network outages and like all this stuff. Yeah. And my move into the NOC, I have a lot of visibility into that.
And so when you talked, Shannon, about like having that discussion and doing a transcription of that discussion, did you like take a transcription of it or something and then feed into Claude projects to kind of like structure the knowledge gained from that free form conversation? Okay.
Yeah, exactly. And I was actually really surprised at how good it was at bringing it in and kind of connecting the dots. But we had that transcription, and then we also had the synthetic data that kind of matched that scenario as well. So we chose a scenario. Him and Shah has kind of talked back and forth about the infrastructure, and I kind of guided the questions along the way, so it could be like still project oriented, and then that was fed into Claude, and we started designing the prototype at that point.
Very cool. And then I know there was a lot of mention of Salesforce, so I didn't know that we had data in Salesforce, that we even use Salesforce. Like we do use Salesforce, and like what's in Salesforce that's not in Databricks or not in MS SQL or not in Teradata?
So based off of a meeting that happened yesterday, with my manager's manager, something like that. They were stating that we were kind of transitioning to Salesforce, right? We were kind of moving away from using the applications or the applications that we currently have in our environment. We're going to be kind of pushing for like Databricks and like Salesforce applications and stuff like that. I kind of built a lot of the the production, I guess, futuristic view based off the knowledge that, hey, if we were to transition to this environment, this is what it would probably it would look like. But if we were to take out Salesforce entirely, we would just still use like Databricks as our main thing. And then like other platforms that we use to like host all of our applications and whatnot and pull those data sources.
What are the name of the apps that you're currently using that you would basically migrate to Salesforce if you do go to Salesforce?
Okay, so for the customer facing side, that would be a little bit more of Shannon's realm, but
yeah, and we do use Salesforce on back office and field service.
Oh, okay. So we already do use Salesforce for certain things. Okay.
Exactly.
Interesting. Yeah. So it's just that we'd be using more of it, right?
So if you see iCase in some of the data, that's Salesforce.
Oh, I didn't know iCase was something that was in Salesforce. Oh, okay. Okay.
That's interesting. Yeah, I didn't know we use any Salesforce stuff.
And so when you were developing this, so you were in that toy environment that had been set up for you in the hackathon, and you created the synthetic data in that toy environment. But when you were building in the toy environment, is that when you were using sort of like Cursor to do the coding, or were you ever using Claude Code within that environment? Like how did that work for you guys?
We used
Okay. Yeah. Continue.
Conquer
You can
to,
go.
oh, so, we used
All right.
Conquer to create the synthetic data and then use Claude to build out the prototype.
Got it.
I would like to add, I didn't use, so there's some components to the application that we like. There's differences between Claude Code. Like I see the big difference between like Gemini, Claude, and ChatGPT. And one thing that I picked up a lot is like the best application in my experience is like anti-gravity. If you guys ever heard of that.
Yeah.
It just came out recently.
Yeah.
It tremendously helps a lot in terms of building out systems that are like structured to scale and all that.
But for the hackathon, you didn't use anti-gravity, right? You didn't have access to anti-gravity at that point.
Oh, I used anti-gravity. Yeah.
Oh, you did? Wait, did you like?
Okay.
You used it for the front end, right? The portal.
So I used it to make the back end and the front end. So they gave so I guess I'm messing up names, but the rest of my team, they built out the front end using HTML, CSS, and like a little bit of JavaScript to make this huge HTML file, right? Mm-hmm. And then I broke out that HTML file into a backend with Python scripts and SQLite database. And then the front end, I took their HTML, CSS file, and I basically broke that up into a functioning HTML, CSS file, but that look a React file that has like API fetching back and forth with the front end and back end, and communicating with the SQLite database and all that. So,
but that's the actual code you're talking about. I'm asking about what was the code assistant that you used to build that code, and so that's why I'm
Gemini
like,
3 Pro.
I thought the AI COE made this huge fuss about, hey, if you do anything in Hackathon, you have to do it in our tour environment using our approved, Cursor AI or Claude Code environments. And so that's why I'm just like, did you just like, and it's okay if you did, I don't care. But
no.
Did you go outside of that and use anti-gravity separately and then bring the results of anti-gravity coding back into the toy environment?
So so how Claude, so in Claude you can, usually people are using like VS Code and Cursor and whatnot. Anti-gravity is basically another wrapper, but for Gemini models, right?
Right.
So
I said anti-gravity was not an approved coding assistant within the hackathon.
I asked them, I asked them, and then they're like, yeah, that's fine.
Okay, so they were like, it's in a toy environment, so do whatever the hell you want, basically, which is why it was
exactly
cool. Okay. That's where that's because I didn't participate in the hackathon, so and I could see that happening too. It's which is fine. And so you had a chance to actually use anti-gravity and you loved it, which I'm not surprised, like, because it's very cool. Okay.
Yeah.
And so and then
Shaz might have been a unique case too, because from his work computer he couldn't access the environment, the play environment. So he worked a lot with the data buddies to kind of work around that as well. So everything was like approved through that third party that hosted the hackathon.
Okay, very cool. And then if you were to, so like this, like what you proposed, it has lots of different components to it overall, right? It's there's a lot of different pieces to the overall architecture of this. And so if you were to like try to take some of this and make it like production quality on messy production real data, like which component of it would you tackle? Like, would you consider tackling like, oh, I'll try to take something from the very beginning to the very end of this architecture, but in a very sort of limited use case? Or would you like, no, like, let's try tackling like this beginning module or this module that's kind of in the center and see if it actually works in reality? Like, what are your thoughts to you, Shannon, and to you, Shaz? Like, what would you consider viable to test?
I would say layer one. I would say the data. Right now, currently, our systems are all over the place. Even old siloed applications that are old applications that need to be archived and done with and thrown away. Instead, we just take those databases and we again take those, form those in. Some of this stuff isn't even put into Databricks, but it can be. You know, uh, filter all that stuff, filter all the like the data and everything like that through the Databricks Medellin structure. And then we take the AI agents, like using Mosaic AI. I've been reading a lot about Mosaic AI with Databricks and stuff like that, and using those same concepts that we have, like the deep end Louis and stuff like that, and we build models based off of that, or we build our own predictive models based off of that. You know.
Yeah, so
And
that would
then,
be Agent
yeah.
Bricks, Jonathan, in Databricks. That's built on that Mosaic
Okay.
AI.
Right.
Yeah.
And Agent Bricks, that's a relatively new development, Agent Bricks, isn't it?
Right.
Within the Databricks ecosystem that just kind of almost came out for use.
Yeah, it came out in like August, September, I believe.
Mhm.
But there's actually an RPA layer that we envisioned with this too, is because like the like, let's take the order management process, for instance. Like if you needed to place an order for a new part, like that's all manually done. So it would really just be the agentic AI kind of starting that RPA process. As
My
opposed
understanding is
to,
the current RPA process within Frontier, it's off of some platform called Photon. Is that still the case, or are you familiar with that, or that not all of RPA is in Photon? Some of the RPA is
not
outside
all of
Photon.
it. No, some of it's automation anywhere as well.
Okay. Very cool. All right.
Yeah, which I love that platform.
Photon.
Automation anywhere.
Oh,
I don't,
automation. Okay.
yeah, I haven't had any experience with Photon.
Okay. Wait, what is automation anywhere? Like it's another platform, or it just
Yeah,
means
it's like a drag and drop RPA.
It's like NAN or Make or one of those applications. It's just like
Well,
that.
Make's better, but Make is like RPA for agentic AI.
At this point, I would
Same
say
with Mind Studio.
they're all wrappers of the same thing. It's just who can get the best companies to work with them. That's the way I look at it.
And are there connections, or has anyone made connections within Databricks to what'd you call it? API Anywhere? What would you,
Automation Anywhere.
Automation Anywhere? Are there actual, has anyone deployed actual connections between Databricks data and Automation Anywhere?
No, but
Yeah.
we do, like with the Agent Bricks, you just deploy to an endpoint.
Right. Okay.
So it can be pretty much placed in almost any application.
Okay. Cool. Hey, James, did you have
That's
any
2026 for me.
Yeah.
I did have a question. I'm gonna pull out of the high tech design aspects of it real quick and speak more on a pragmatic, practical application. Maybe this could have enhanced your revenue savings, or shall we say, expense reduction. So I think this is really compelling and powerful. And when you look at the way our network is managed, just speaking from pure experience, both as a CCNA and an FNFT, it's very, in my opinion, it's very poor. It usually is an alarm will go off, or somebody will make a phone call, and by that time it's 100% reactive, which is pretty weak, I think, given this day and age. So like one of the things I'm curious about is, from a network management resource allocation tool, how does this interface within our network, starting like from the central office to the gateway router, to the hub port, to the terminal port, to the ONT, and then to a router or a phone line. And if you look at that line of connections, if you will, it can start, the issue can start at any of those. So it may not be an actual network issue. It might be an ONT, or a router or a hub port fail. How does it interface into our network, and then to actually identify the specific issue, which again turns something reactive into proactive? How would it then position itself to take action?
So this is the most interesting, I think, my favorite part of it. This graph that we have built out doesn't really show what our network actually looks like. Now, I spent time with within my team to speak to a network engineer, and what he showed me was like, I couldn't believe it. Like, the different aspects of our network, like the OLTs, the DSLAMs, the different nodes, all the way down to the customer, is what even inspired me to keep pushing on, working with the team to find a way to build these. So again, unfortunately, hold on, let me see, battery
But for this
percentage.
scenario, for this, we had to just kind of focus the prototype.
Yeah.
And the idea was it would scale from there. And for this particular scenario, we outlined like Caltrans hitting a trunk, right? And part of that is because like the work that Caltrans does is logged with us before they start doing it. So we have records that would identify like that there is work being done, and then the work being done on the trunk, that we see the alert that there's an outage. And sometimes one of the reasons why we connected the customer experience side or the support side to this network as well is because sometimes we get alerted of outages through the customers themselves. And that's why you can get into the granular level at the agent level even and see, okay, well, this person in this area is experiencing an alert. And that's why we just wanted to tackle one knock at a time and then just design to scale from there.
Well, that's a beautiful thing. And I do think, as you said, it's almost like an initial step into a final amazing solution that, again, from a network management allocation, resource allocation, can turn something that has historically been horribly reactive into something that would be extremely proactive. And that would be, given that we do have the premier internet in the industry, and we, the most advanced technology, essentially, it would decimate our competition. And there's other implications in relation to market development and acquisition and also retention from that perspective. But I don't know. I really wish I had an opportunity to be a part on this as well, Shannon. That would have been
yeah,
fun.
I would have loved to have had you on this team. I think you would have loved this project. But
so cool.
To your point, like that's the whole concept behind Priority Parker. Like tickets would come in and there'd be hundreds of them, and how do you prioritize them, and how do you associate them with the correct outage? Like that's kind of a manual process currently. So that's why we thought an agentic AI would be perfect for that solution. Just based on that criteria that you saw in the analytics, it can help prioritize the ones with the biggest revenue impact, for instance.
True.
And that's something our network engineer kind of called out as well.
Definitely. And downstream, you can tie this ultimately into how trouble tickets are issued to a technician using dispatch. If you really want to get crazy, you could identify which technician was potentially idle or closest to that, on and on and on. But that's
what
this
dispatch
is really
Dana does. And then Circuit Charlie gives you the probability of the failed circuit, because what our network engineer outlined for us is that there might be a failed circuit between like Chicago and Minneapolis, right? And I'm exaggerating a little bit, but then you have to send out an engineer to kind of go to one part and say, okay, was is that the one that's broken? No. Okay, go to the next one. Is that the one? No. So that again is a manual process. Whereas Circuit Charlie can identify, 89% confidence that it's that trunk based on the reports that Caltrans, submitted, and they know that we're working on at that time, and the different tickets that are coming in based on that information. Charlie calculates a probability that it's that trunk in the chain.
It's really cool. I think that scroll up a little bit on that sentiment, Sophie, if you can. That's really cool.
Check them out at the top.
Take this on and run with it. So those are my 2 questions.
I guess to say for the first question,
Cursor AI versus Claude Code versus anti-gravity, or like, is your current impression like, yeah, anti-gravity was awesome. I'm fine with Cursor AI. I'm fine with Claude Code. They're cool too. But like in a perfect world, I would just be pure anti-gravity, or were you like, no, anti-gravity was just so incredibly much better than anything else? Just curious. And then the second question to everybody is just like, so like, where do you guys go from here? Like, are there particular discussions of you like nibbling off bits of the current applications of this and continuing on, or like, are you kind of in a holding pattern, like other people are going to take this on and run with it? So those are my 2 questions.
I guess to say for the first question, Claude Code is really good at creating. Claude Code is really good at creating websites and visually appealing things. But with the right directions or right parameters, you can create really good applications as well. But again, that's where the parameters and stuff go. Gemini within anti-gravity is a mind-blowing application or AI model. But again, I'm very much so on the path of, if it's not done right or if it's not within the right parameters, it could cause a disaster. Same thing with ChatGPT. And ChatGPT at this point in time, if you're using the API to code or anything like that, you're kind of lost. So the only 2 things the only 3 models that I would say, if you were going to work with Gemini as much as possible. Gemini 3 specifically. And then Claude Code to make anything look beautiful. And then again, use both with parameters. Now to the second question. No. You guys are the only people that you guys are the only people that decided, hey, I want to take a second crack at this and look at it. I was talking with the network engineer and hoping that I'd be able to work with other network engineers and build out an actual graph that states each node as like the OLTs and ONTs and all the way to the highest node of like D-slams and all that. But even that kind of got shot down as well, because a lot of people didn't want to be innovative. And I think where it came off to me and what I got information is it scared people by removing their jobs, when this doesn't remove their jobs at all. This just enhances and makes things a lot faster, if that makes any